All right, 3.1c lesson. We're going to be talking about lots of vocabulary here because we're getting ready to do some simplifying expressions. Okay, so in the very top there it says consider the following expressions: 2x plus 5 plus 3y, 2x plus 5 plus 3x, and 2x plus 5x plus 3x. How are these similar? How are they different? All right, so I hope that you're noticing that all of them have 2, 5, and 3 in each, but the letters are different. Okay, so that's really all that I'm noticing, just looking at those to start. Okay, all right, this box right here is key. This is important. You need to know this. You will be tested on it. You will be quizzed on it. Okay. All right. Components of an algebraic expression. Use the diagrams below to come up with definitions for the following vocabulary words. Be prepared to discuss your definitions with the class before you write in those definitions. Okay, so terms, constants, coefficients, like terms. You need to know what those four mean. Okay. All right, let's talk through this box and then we will define them down here below. All right, terms. Terms are numbers, variables, or products of numbers and variables separated by addition. Okay, so when you have a minus sign, please understand that you could rewrite this as a plus negative. As a plus negative. Okay, so aren't all these terms separated by a plus sign? So we've got x, -4, 2y, 3, and -5y. That's what this says right here. We have x, -4, 2y, 3, and -5y. Okay, those are terms. Constants. Constants are a fixed value. They do not vary. They do not vary. So anything that has a letter with it is not a constant. Okay. These are our constants in these problems. Please make sure you think of this -4 as a plus a -4. Okay, so -4 and 3 are our constants. Okay, coefficients. Coefficients is the numerical factor of a term. Okay, so anytime you see letters in your expression, you look for the number that sits with the letter. So this is a letter, there's the number, okay, it's a hidden number. It's a number 1. Okay, that's where that 1 comes from. This 2 is a coefficient. And don't forget, this is plus a negative. So don't forget that that minus, you need to have a -5 on the coefficient. Okay. Now for like terms, you are looking for terms with the exact same variables. Okay, so -4 and 3 have the exact same variables. There are no variables. Those are the same variables. Okay, 2y and -5y have the exact same variables. They have y's. Okay, so 2y and -5y are like terms, and -4 and 3 are also like terms. All right, so let's get some definitions down here. Okay, so terms. Terms. A number, or variable, or product of numbers and variables separated by addition. separated by addition. Okay, that's the definition for terms. The definition for constant, a fixed value, not a variable. A coefficient, the numerical factor of a term. And then like terms, terms with the exact same variables. Okay, so those are the definitions. Now, this chart down here is very important. You will see this on quizzes, you will see this on tests, you will see questions like this on the dots. I'm going to tell you guys right now, you need to know, given an expression, how to find the terms, the constants, the coefficients, the like terms. Please do not enter a dot. Please do not enter a quiz. Please do not enter the test without knowing what those are. If you don't understand what those are, you better ask, okay? All right, so terms in this problem right here. First of all, I would recommend that you change everything to plus signs. If you change it to a plus sign, you'd have a plus and negative on that x, okay? All right, so your terms, 7x, negative x, and 8y. Notice that they are separated by commas. Okay, do not lose the negative on the x. Okay, the constants. Remember the constants by the definition right up here. You're looking for just the numbers. If you see a variable, avoid it. Okay, so I don't see anything in this that's just a number. They all have letters. So my constants, there are none. Okay, now coefficients, I'm looking at all three of these. My number with the x in this term is the 7. My number with the x in this term, tricky, don't be tricked, -1. My number with the y in this term is 8. Those are my coefficients. Okay, now my like terms, my 7x and my -x are like terms. They have the same variables. Okay, all right, that's number 1, or the first row, I should say, of number 1. Let's look at the second row. Terms. Okay, and again, I'm going to take a moment. T plus 3c plus 5a plus 4t plus a -6. Okay, so I got my terms. A t, a 3c, a 5a, a 4t, and a -6. Okay, I listed everything out separated by commas. Okay, my constants. The only thing in this expression that doesn't have a letter is this -6. That's the only constant in this problem. Now the coefficients, you're going to pull out the number, the numerical factor in front of all the letters. So the number in front of this t, don't be fooled, is a 1. The number in front of the c is a 3. The number in front of this a is a 5. The number in front of this t is a 4. And this doesn't have a coefficient because it's just a constant. It doesn't have a variable. Okay. Now for like terms, the only like terms I see are t and 4t. T and 4t. Okay, any questions so far on that before we get going? All right, this guy, I'm going to take a moment and do n plus a -3 plus a -2n. All right, now I can clearly see my terms, n comma -3 comma -2n. My constants, the only thing here without a letter is this -3. My coefficients, I look at all the letters. The number in front of this letter is a 1. The number in front of this letter is a -2. Okay, and then like terms are the terms with the n's, n and -2n. Scooch that up. Okay, we have one more here. All right, so let me take these minus signs. 7a plus -5b plus -10 plus 6. All right, so I rewrote everything with plus signs. That way it's very clear to see 7a, -5b, -10, and 6. Okay, my constants, the only, well, I see 2. -10 doesn't have a letter and neither does 6. -10 and 6. Now my coefficients, I look for everything with letters and I pull the number out in front. So I see an A right here, so a 7 is in front of it. And I see a B right here and a -5 is in front of it. The like terms in this problem is the -10 along with the 6. Okay, you absolutely need to know how to do this problem. This is very important, okay? All right, next page. All right, commutative property. Commutative property, the word commute means to travel or change. It's most often used with regard to a location. For example, we say people commute to work. For each of the following pairs of expressions, the operation is the same, but the constants have been commuted. Determine if the pairs are equivalent or not and be able to justify your answer. From these pairs, we're going to define the commutative property. All right, so it's very important to understand if I leave my house and go to Earl Warren, and I go Earl Warren to my house along the same roads, haven't I gone the same distance? Isn't that an equal distance? Okay, that's what you should be thinking of when you hear about commute. All right, 12 plus 4 is 16, and 4 plus 12 is 16. These are equivalent. 12 minus 4 is 8. 4 minus 12 is -8. These are not equivalent. 5 times 4 is 20, and 4 times 5 is 20. These are equivalent. 18 divided by 6. 18 divided by 6 is 3/1. 6 divided by 18 is 1/3. These are not equivalent. Okay, so I am noticing, what patterns am I noticing? Add and multiply, work, subtract, and divide don't work. Okay, so it's very important to understand the commutative property. There are 2. Okay, there's the commutative property of addition that says any number plus a different number equals the reverse of that. And then there is A times B equals B times A. Any number times another number equals the reverse. Okay, that is the commutative property. All right, on to associative. Associative property. The word associate means partner, connect, group. Most often we use the word to describe groups. Okay, if a person goes to Eastmont Middle School and not Indian Hills Middle School, we say that person is associated with Eastmont Middle School. Okay, we're going to do the same thing. For each of the following pairs of expressions, the operations are the same, but the constants have been associated in different ways. Determine if the pairs are equivalent. Be able to justify your answer. From these pairs, we're going to define the associative property. Okay, it's important to understand this concept. Let's say that you have two friends. You have two friends. Their names are Juan and Sal. All right, Juan and Sal. So you go pick up Juan in your car. You go pick up Juan. Together, you go pick up Sal. The three of you are in the car. Okay. Let's say that Juan goes to pick up Sal, and then together they go pick up you. The three of you are in the car. Okay. So it doesn't matter in the end who gets picked up first or who gets picked up second. You're all in the car at the end. Okay. All right. So let's look at this as it relates to numbers. All right, so PEMDAS from 6th grade says do what's in parentheses first. So 12 plus 4 is 16 plus 6, that's 22. This would be 12 plus, we got to do the 4 plus 6 first, which is 10. Okay, so I'm getting 22 there also, so this is equivalent. Okay, this would be 8 minus 3, which is 5. This would be 12 minus 4 minus, that would be 11. This is not equivalent. Okay, this would be 12 times 5, which is 60. And this would be 6 times 10, which is 60. This is equivalent. This would be 3 divided by 3, which is 1. And this would be 18 divided by 2, which is 9, not equivalent. Oops, sorry guys, I have to move that up. Not equivalent. Okay, so the patterns that I'm noticing again are add and multiply, work, subtract, and divide, don't work. All right, so the associative property, there are two. A plus B plus C equals A plus B plus C. Parentheses are around different groups, but they're all the same in the end. A times B times C equals A times B times C. Again, parentheses around A and B here, parentheses around B and C here, but they're all the same. Okay. All right. Substitution property is given down at the bottom here. It says we use this property when we substitute one number or expression for an equivalent one. For example, 2 plus 3. 2 plus 3, you guys, 5 has been substituted for 2 plus 3. Okay, so that is an example of the substitution property. Okay, we're going to get into some proofs. Okay, and these are challenging for kids. These are a little challenging every year for kids. All right, so name the following property: commutative, associative, or substitution, used in each step in the simplifying the following expressions. All right, so this expression right here is given. What happens from this expression to this expression? Do you see that the 1 and the 4x were flipped around? The 1 and the 4x were flipped around. That's called commutative. Okay, now what's happening from this expression to this expression? Do you see parentheses were put in there grouped around the terms with the X? So that's associative. 3x plus 4x in this expression, what changed into this expression? We added those together to get 7x. So that is substitution. Okay, let's look at number 3. So this is the given expression, given. What's changing from this given expression to the next expression? Can you guys see that that 3 plus 2y came off the paper, flipped around? Okay, so that's called commutative. From 2y plus 3 plus 7, what changed from there to here? Oh, parentheses went in and grouped together. Associative. And then the 3 plus 7 changes to a 10. That is called substitution. Okay, don't be thinking that they're always commutative associative substitution. Okay, I think the next one's a little different. All right, this guy. What changes? This is our given expression. What changes from here to here? Do you see that the parentheses scooched to group something different? That's the associative property. Okay, now from this one to this one, 7x plus 8x became 15x. That's substitution. And then 5 plus 15x became 15x plus 5. That's commutative. Okay, so that's a proof if you're given the steps and you just need to come up with the justification, the reason, the property. Okay, now let's do a couple where you have to do the entire thing. Okay, so we have to do some steps here, and then we have to come up with the reasons. Okay, so my first thing I'm going to do is I'm going to take and commute the x and the 3. Couldn't I also commute the 6x and the 3? I want the x's by each other. I want them by each other. So this was commutative. Okay, and then I'm going to group together the x terms. That's called associative. And then I'm going to add together, I'm going to simplify 6x plus x makes a 7x by substitution. Okay, the next one. 9 plus 7y plus 1. Okay, I'm going to go ahead and I'm going to commute the 7y and the 9. Okay, and then I'm going to group together the 9 and the 1. And then I'm going to add together the 9 and the 1, and that's called substitution. Okay, so that ends 3.1c. There's a lot that needs to be memorized in this lesson. We really haven't had a lesson yet where you needed to memorize vocabulary. This is one of them. Please make sure you're doing that. Do not enter a dot, a quiz, a test without having memorized what the vocabulary is in this lesson. Okay, you will see them on your assessments. Please make sure you understand and know them. Okay, thanks guys.